In Unit 11, P block elements, Standard 11, Lecture number 5, 11.3, topic number some important compounds of boron. We continue. First we finish borax, then orthoboric acid, then we continue with diborane. Remember here it is a very simple format of diborane. Di indicate 2 and boron is there, that's why it's a B2. Okay, and formula is H6. So here general formula is BnH n plus 4, BnH n plus 4 or B2H 2n plus 2. Okay, so this is the we consider general formula of diborane, and the simplest boron hydride is B2H6. Here you have to learn about B2H6. Okay, so first of all, this is the simplest boron hydride. Hydride indicate what? Boron and hydrogen, two element is present in this diborane, and due to that we can say that it is also considered as BH3, and that's why it is called B2H6. And this boron hydride or say diborane or say boron hydride is there, they possesses one bridge bond. Okay, and there is hydrogen bond, bridge hydrogen bond between two boron atom. That one just we see later on, but here it is very important. Diborane formula is B2H6, simplest boron hydride is B2H6, and formula is we can say BH3.BH3. Preparation. Now see, it is prepared in presence of boron trifluoride. Boron trifluoride when treated with lithium aluminium hydride in presence of diethyl ether. This is act as a catalyst. It gives 2 moles of B2H6, 3 moles of LiF and 3 moles of AlF3. Complete the reaction. It's question asked many times. So just you remember that. First of all, remember preparation. So we can say that boron trifluoride plus lithium aluminium hydride is there. So here Li is there and F is there. That means LiF certainly out in the product. It's a byproduct. And another thing, we have to prepare B2H6. So here 4B is there. That means here 2B2. And here 4 3s are 12 is there. So 6 2s are 12. So here we have to take 2 moles of we can say B2 and here H6. So another see 3 Li is there. 3 F is there, 3 LiF. Okay, another 3 Al is there, and another we can say that here 3 F is there. So 12 minus 3, that is 9. So here 9 fluorine is there, and here 3 aluminium is there. Therefore 3 AlF3. Complete the reaction. This question asked many times. So we have to perform just like this with preparation. Okay, and this lithium aluminium hydride is a strong reducing agent. It provides hydrogen to we can say that boron trifluoride. Okay, and that's why here P2H6 is formed. Laboratory method. In laboratory, sodium borohydrate when reacts with I2 oxidation reaction, that is considered as B2H6 twice NaI plus H2. So how will we perform this? You see, B2 is there, and from this H8 H6 is there. So here H2 gas is evolved because 2H is remaining. And I2 is nothing but twice I minus and twice Na plus. It gives twice NaI. So first of all, remember here Na is there and I is there. So NaI certainly out of this we can say that byproduct. Another here B2H6. First of all, you write down. Now which thing is left? So you write down this plus H2. So this is a laboratory method to prepare this B2H6 or say diborane. Industrial scale. Industrial scale, you have to take hydride. We have to take alkali hydride. So here 2 moles of boron trifluoride when it reacts with 6 moles of sodium hydride, not hydroxide. So 6 moles of sodium hydride at 450 Kelvin temperature. Then here B2H6, this we can say that diborane is obtained. Just you see here also it's a very simple 2B and here 6H is there, and that's why B2H6 plus 6Na, just you see 6Na, and here 3 2s are 6, so 6NaF. Complete the reaction. This type of question asked many times. So it is a very important preparation. First of all, from boron trifluoride treated with lithium aluminum hydride in presence of diethyl ether. Another sodium borohydride. It is reacts with I2. Okay, this is ion demethyl reaction, and this B2H6 and twice Ni plus H2 we get. Another industrial scale boron trifluoride reacts with 6 moles of sodium hydride. That means first of all strong reducing agent, another I2, another sodium hydride. Okay, and 450 Kelvin temperature it gives B2H6. So this is 6 moles of NaF is obtained. So this is all about preparation. Now properties. Properties is a very interesting. Colorless. It is a colorless. That means white color. Highly toxic gas with a boiling point 180 Kelvin. Normal boiling point or say normal temperature is 298 Kelvin, and just you see 180 Kelvin is there. So it catches fire when it is being opened in a air. Okay, so it's a very important property. And DIBORANE catches fire spontaneously upon exposure to air. Write it completely because it's a very important. DIBORANE catches fire spontaneously upon exposure to air. It's a colorless, highly toxic gas with a boiling point 180 Kelvin. Now, this borohydrate, or say we can say that DIBORANE, when reacts with oxygen, it gives B2O3. Is it clear? Boron oxide. Boroxide, and 3 moles of water molecule. It's a very simple formula. Just see, B2 is there, and here O3. In same way, O2 and H6 is there. So here you have to write 3H2O. Okay, that's why you have to remember here O3, but 3 to the 6 O is there. Okay, so first B2O3 and then 3H2O. Write down this name, and this delta H0 is we can say an exothermic reaction. Once again, DIBORANE catches fire spontaneously upon exposure to air. So it's very important. So minus 1976 kilojoule per mole. This much energy they released. Okay, and that's why it is a we can say that exothermic reaction is occur when it's exposure to air. Most of higher boranes are also spontaneous flammable in air. They produce flames. They are just ignite very easily. Okay, flammable in air. Here catches fire. Meaning of this flammable means that. Another B2H6 when reacts with 6 moles of water molecule, it's readily react hydrolyzed because H2 is there. It's hydrolyzed in terms of just you see 6H2 is there and 6H2 is there. So here you have to take 6H plus and here 6OH minus. Here B2 is already there. So 2B and OH thrice. So here we write 2BOH thrice. This 6H plus is converted in terms of we can say that 6H2 gas. Okay, so here 2BOH thrice and here plus 6H2O. Because just you see this B2 is there. Okay, 2B and this H6 is also there. Just you see this H6 is also there. That means here H and here H. So 12H. So here how many hydrogen gas is released? 6 moles of hydrogen gas is released. So this type of question may be asked in your competitive exam. When DIBORANE reacts with water, it gives how many moles of dihydrogen gas? So it's a very easy, readily hydrolyzed, and how many moles of hydrogen gas is released? So 6 moles of hydrogen gas is released. So that's why different types of question is asked here. Another, this B2H6 when reacts with trimethylamine, okay, this organic compound. 2 moles of trimethylamine. Due to this nitrogen having non-pair of electron, 2BH3, that means BH3, 2BH3 dot and Me3. Here this structure is we can say tetrahedral, and here bridge-like structure, and here also we can say that tetrahedral structure. Okay, so this type of formation takes place. Another B2H6 when reacts with 2 moles of carbon monoxide. This is a Lewis base. They have tendency to donate electrons. So here 2BH3.CO borane adduct is obtained. So this reaction is very important for competitive exam because it's a corner question. Remember, B2H6 we can say that this DIBORANE is a Lewis acid. This is a Lewis base, and that's why here this borane adduct instead of any Me3 or CO if we write N, then product is 2 BH3 dot L. L stand for, here we can say that Lewis phase. So remember this and write it completely. Another, these 3 moles of B2H6 when reacts with 6 moles of ammonia. So this is a very interesting reaction. 6 moles of ammonia is there. So here NH3 plus NH3 gives NH4 plus and okay. Here first of all this B2H6 is there. So here we write down NH2 minus and H plus. Okay. So that's what happened. Just you see. Here NH3 is there. So NH3 directly reacts with boron. So BH3 and then NH3. This B2H6 you write down this way. BH3 BH3. This is the way. Another 6 moles of NH3 is there. So here suppose 3 to the 6 moles of NH3 is attached with this position. Okay, two are there, and that's why here it's obtained BH3 NH3 twice and plus. Is it clear? BH3 NH3 twice and here plus. And suppose here this H plus is reacts H minus from this borohydride is reacts with ammonia, then boron, sorry, BH3 at that time BH4 minus is obtained. So this is a very important, we can say that complex compound, cationic and anionic complex compound having boron. So here B2H6 is there, due to that NH3 and NH3 is there, that's why NH3 twice. Okay, and here BH4 minus. So here we have to write to 3 moles of B2H6 is there, and that's why here 2 moles of BH3. Okay, so here 3 moles of BH3 and NH3 twice is obtained. So 3 to the 6 and 3 BH3. Okay, it's over. Now another BH3 is remaining. So plus this is the plus and another H minus is there. So H minus, so BH4 plus. One is H minus and another is H plus. So according to that, here BH3 NH3 twice plus BH4 minus. This type of product obtained. In your textbook, maybe it's written NH3 twice. Okay. And when we heat at that time, this hydrogen is removed in the form of hydrogen gas. So here 2B3 and 3H6. This is known as inorganic benzene, which is known as borazine. Okay, it is written in your textbook. Yes, it is written that's inorganic benzene. Its structure is alternatively B and NH. Okay, BH and NH, and that's why just you see B, so B3, N, N3, and here H6. And due to that, we can say that B3 and 3H6 borazine. In your textbook it is written borazine is obtained. So this is all about this. This is very interesting reaction. You write it completely. Okay, how borazine is obtained from diborane. So it's the one type of conversion. So from diborane you have to add 6 moles of ammonia. It gives 3 moles of BH3 NH3 twice plus and BH4 minus. Okay, double complex, cationic complex and anionic complex. If we heat, then just you see how many moles of hydrogen is there. They are removed. So here B3 and 3H6 is obtained. This is nothing but inorganic benzene, just like C6H6. Okay, so this is known as borazine, and plus 12 moles of H2 gas is released. So here all about diborane. Now we switch on towards the structure of diborane, which is a very interesting. Make a screenshot of this, write it completely according to your NCERT textbook. Okay, now structure of diborane. Actually the formula is B2H6 and it is made up of, we can say that BH3. So electronic configuration of boron Z is equal to 5, 1s2, 2s2, 2px1, 2py0 and 2pz0. 2 boron is there, so boron Z is equal to 5, 1s2, 2s2, 2px1, 2py0 and 2pz0. But according to, you know that there is a screening effect, which is a strong, we can say that, of 1s orbital. This 2s containing electron enter into p1 and this 2s containing electron enter in another to p1. So here this is considered as valence shell. So here in 2s orbital 1 electron is present, to px also 1, to py also 1, but to pz do not possesses any electron. Same way here 2s 1, to px 1, to py 1, but to pz do not possesses any electron. These three hydrogen donated their electrons according to this way. That means this 1, 2, 3, 4, 5 and 6. So 6 hydrogen is there. They are donated their electrons. That means H3 is there. That's why they donated electron, hydrogen, hydrogen, hydrogen. So this is, we can say that now not 2s orbital or 2px orbital, but it is considered as sp3 hybrid orbital. sp3, this is also sp3, this is also sp3, this is also sp3, this is also sp3, 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 and this is also sp3 hybridized orbital, which is give the electrons towards, we can say, boron and hydrogen sharing their electrons. This is a 1 hydrogen, 2nd hydrogen, 3rd hydrogen, 4th hydrogen, 5th hydrogen and 6th hydrogen. But just you see here, very important matter is this, that this boron, 2 boron is there, this boron and this boron is there. They sharing their electrons with here hydrogen, no problem, here hydrogen also no problem, here hydrogen no problem, here hydrogen also no problem. But this boron and boron sharing their electrons with hydrogen at here, that means this boron sharing with another hydrogen. So here we can say that different type of construction takes place. So 2 boron is there, that means they are sharing their electrons with 2py and 2pz orbital. It's not written at here, but this boron and hydrogen, they sharing their electrons. According to this structure, we can say that BH3 is just like this way and BH3 just like this way. But here this hydrogen and boron, this sp3 hybrid and this sp3 hybrid, they give this type of structure in which we can say that 2 center is there and 3 electron is there. 2 center and 3 electron. Due to that, here we can say that here bridge PHB obtained just like this way. Suppose here boron is there, here boron is there, hydrogen, 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 and above side hydrogen and below side hydrogen. That means in NCERT textbook it is written that 4 hydrogen and 2 boron atom, they are lying in a same plane, and this bridge hydrogen are, we can say that, in a upper and lower side of the hydrogen. We can say that this particular plane, okay, vertical of the plane, and that's why here bridge is obtained. And this bond is considered as, just you see, this type of bond is there, just the shape is a banana shape. That's why this bond is considered as banana bond. Banana bond. Okay, and this type of, we can say that, hybridization is sp3, but here not sp2. Remember, here sp3 hybridized orbital, and that's why I write here sp3, because sp3, it's actually here sharing of electron with respect to hydrogen also, and that's why here 3 center to electron. 3 center, this 3 center, boron, hydrogen, boron, they are element, that's why 3 center. And how many electrons they share? They share only 2 electrons. So 3 center, 2 electron, this type of construction takes place, and that structure is here. So here this boron, hydrogen, 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 they are in a same plane, and this is, we can say that, below and above side of the plane. And this bond angle HBH is 97 degree and BH bond length is 134 picometer. But this HBH, this bond angle is 120 degree, but this B and H, this bond length is 119 picometer. Do not remember this particular data, it is just for information. So this is all about the structure of diborane, and certain we can say that sentences here written in terms of boron hydride, BH4 minus is there, tetraborohydride also known and prepared. So 2MH plus, that means what? 2MH plus B2H6, it gives BH4 minus, or say we write 2N plus and BH4 minus. This type of complex is formed, and this is nothing but we can say that metal is stand for here lithium or sodium. Lithium or sodium. Those possesses hydride, they react with B2H6, and that's why 2N plus BH4 minus. LiBH4 or NaBH4. This type of compound is formed. So here three center, we can say two center and two electron is here. 2 center, 2 electron is here, but here 3 center and 2 electron is there. So okay, another term 3 center and 2 electron is there. They are sharings, and due to that we can say that the banana bond is formed. It's a very important. So write it completely. Both LiBH4 and NaBH4 are used as a reducing agent. You know very well. They are known as reducing agent because this hydrogen is provided by 4 hydrogen, and that's why it acts as a reducing agent. It is important in reduction reaction. When hydrogen is required, it is very important. Another, we can say that they are useful starting material for preparing other metal hydroxide. It is also known. Now, next your topic is regarding, we can say that uses of boron and aluminium and other compounds. This is a very important. Just to write down from your NCERT textbook. But write down according to this way, and this sp3y here actually sp2 is there, but here this orbital is also take part in 3 center 2 electrons. Okay, and that's why this is considered as 3 center 1 2 3 and 2 electron take part. This boron haven't any electron, but this hydrogen and this boron have electron, and that's why they donated with, or say they are bonded with boron. Same way here BH3 and here also BH3, but they bonded with hydrogen. So it's a not hydrogen bond but B2H6, so BHB bond is formed. Okay, so this is considered as banana bond. Okay, so this is all about structure of boron. Write it completely. Okay, now uses of boron and aluminium in their compounds. Now this is actually a homework, but yes, this is very important. Boron, extremely hard refractory, solid of high melting point, low density and very low electrical conductivity. Okay, boron fibers are used in making bulletproof vest and light composite. This is very important. Bulletproof vest and light composite material for aircraft. In aircraft, certain light, we can say that particular metal like any plates is required. At that time, it's very important. Boron 10 isotopes has high ability to absorb neutron, and therefore metal borides are used in a nuclear industry as a protective shields and control rods. Boron rods are used to control, we can say that certain, we can say that another control rod in nuclear industries. Borax and boric acid in manufacture of heat resistance glasses. Pyrex glass in laboratory, if you see any beaker, so it's a borohydrate, it's a pyrex glass is there. Glass wool and fiber glass, this type of glass wool is used. Okay, it is formed from boron. Borax is also used as a flux for soldering metals. You know that soldering is very important when wire is joined with another, and at that time soldering is there. So soldering to connect in particular, we can say that instrument. Soldering metals for heat scratch and stain resistant glazed coating to earthenwares and as a constituent of medical soaps. Okay, because soft whatever the soap is there, it is due to addition of this boron. Or say borax is there. An aqueous solution, or say boric acid is also there. An aqueous solution of orthoboric acid is generally used as a mild antiseptic. It is a very useful in a eye, when eye conjunctivitis is there, it's there, that solution is very important. Okay, in a hot water. Aluminium, because bright silvery white metal, high tensile strength and high electrical and thermal conductivity. That you know, electrical conductivity of aluminium is twice that of copper. Remember this one? In industry and everyday life it is useful. It forms alloys with copper, manganese, magnesium, silicon and zinc. This can be used in a sets of pipes, tubes, rolls, wires, plates or foils and packing. But this aluminium is a toxic in nature, and that's why that particular use of this aluminium is nowadays aluminium utensils, or say when we use any kitchen material, or say when we use food making any instrument or say utensils, at that time it is avoidable because it's a very harmful, it creating toxic effect. And this is all about uses of boron and aluminium. Just read from NCERT textbook and write it completely. So here lecture number 5 is complete. So uses of boron and aluminium and their compounds, it's here finished. So write it completely. So lecture number 5 is complete, and take a screenshot. Thank you.